Hello, 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 and welcome back to Shiksha Costa. Today we're going to learn how to solve an exponential equation using a graph. So today we're going to learn how to use those graphs to solve for an unknown value that's actually in the exponent of an equation. And you can know that you're successful at this when you can actually do that, when you can solve problems that are using given graphs, or if you're given the equation of an exponential function, especially if these problems arise from all sorts of different real world applications. And you're going to solve those problems by taking the graph and interpreting it, or just by substituting values for the exponent in the equation that you're given, depending on whether you're given a graph or an equation. To start about thinking about this, really we're just going to learn how to interpret graphs here, right? In this situation here, when hiking the Inca Trail, Aditi was told to take altitude sickness pills when she was above 10,000 feet. Now, it's very hard to have an altimeter, which is a little device that tells you your altitude. So she's really has the question: when should she actually be on her medication? The entire trail is not all the way above 10,000 feet, although we start pretty high at about 8,000. At some point, she will pass 10,000. But one of the things that you can carry with you that's really easy to carry, most smartwatches or smartphones have this, is a pedometer. A pedometer tracks how many steps you've taken. And so this is a sort of a general sense of how many of what her elevation would be after however many steps. And these steps are measured in thousands. So after 10,000 steps, she'll still be pretty close to where she started, which is just about 8,000. But as she continues on this trail, eventually she will take enough steps that she will pass the 10,000 feet elevation mark. How do we know when that is if we have a graph like this? Well, if we look at 10,000 here, we know that she is going to be above 10,000 feet, sort of in this area here. And one way I can be more precise is I can draw a horizontal line here and notice and ask myself, where does this tell me, or what does this tell me about her elevation? When should she be actually taking her pills? I'm going to pause here and let you see if you can figure it out. So pause the video, see if you can answer this question: when should she be on her medication? And then resume it when you're done. So to interpret a graph like this, one thing you can do is sort of just place a point right over there, because we know that that's when she first gets above 10,000 feet, and then draw a vertical line down to see when does that actually happen. And it looks like by my estimation, that's around 23,000 steps. And she remains above the 10,000 foot line until she reaches about here, which is just, if I put another point there and then draw a vertical line straight down from there, it looks like it's just a little bit more than 50,000 feet. So I would estimate 51,000 steps. And so to answer this question, when should she be on her medication? When she has passed 23,000 steps on her pedometer, and she should stop taking the pills when she has completed 51,000 steps since she started the hike. In between those two step counts, she will be above 10,000 feet by a pretty good estimation. And that's more or less how you find a value for, if you're given a value for the dependent variable, which, let's say that value is k, whatever that number k is, and a question asks you, hey, when does this happen? What value of the independent variable causes this? It's pretty easy to solve that using a graph. All you have to do is find k on the vertical axis and draw a horizontal line around there, and then just look, where does it actually intersect the graph? And over here, it seems like it intersects it right here and right here. So from those 2 points, just draw a vertical line straight up or down towards the horizontal axis and look to see what values of the independent variable, which we're going to call x, what values make that actually happen. That will be the solution to the question that's being asked. If you're given a value for the dependent variable and you're asked to solve what value of the independent variable causes that, a graph can really, really help. Now, this is all done sort of by hand, and it is possible to do it by hand, although your estimation might be a little bit off from what is exactly correct. If you're looking for a more accurate answer, you can use graphing technology. And in using graphing technology, you can actually graph this horizontal line, y equals whatever this number is, to see the exact coordinates of the point of intersection. For example, let's say that you have a car, and the value of that car after it's purchased, it depreciates, which means it goes down in value according to this formula, where the value V at n is the value of the car in the nth year after it was purchased. When would the car be worth a tenth of its original value? Well, first of all, hopefully you know by now that to find the original value or the starting value in an exponential graph, you just need to look at the a value, the number that's in front of the power. And so it's the car when you first buy it is worth $86,000. 1/10 of that is $8,600. And to find out when the car will go down to here, if it follows this relationship right here, let's first graph the function f of x. Notice I changed it from v and n because some graphing technology doesn't really allow for different variables. And because I changed the independent variable from n to x, I have to change it here as well. So I graphed this function. And to make sure that I can see the entire graph, I know that, well, my car is I need to adjust the window so that I can actually see the curve. These are some really big numbers I'm dealing with. So I set my window to make sure that I can capture this nice curve here that you might see behind here. And the way I did that is I set my x-axis from -3 until 20, because I figured, I need to see the curve for the first 20 years. I figured, not many cars last more than 20 years, so it's probably going to be worthless by then. And then for the vertical axis, I said, well, my car starts at $86,000 and it's going to go down in value from there. So I won't even see the curve if my y-axis or my vertical axis goes up to 10 or 15. I need to go all the way higher than 86,000. So I went all the way up to 100,000. And I wanted to see the x-axis, so I went a little bit below 0 as well. So I went to -10,000. And when I do that, you can see this nice curve behind here. And then finally, I entered y equals 8,600, right? Because that is the value of the dependent variable that I actually want to see. When does this curve reach that? And then I tapped, or you can select or click or whatever it is. You can notice that point, and once you select it, most graphing technology will tell you exactly what that point of intersection is, or at least round it to a very, very good estimate. And in this case, I can see that notice that on the horizontal axis, we're measuring n in years. So after 9.768 years, it looks like it's close to 10, but just a little bit before. But this is the exact value, or as close as the software can give it to me. At that point, after those many years, the car's value, the y value of this curve at that point is 8,600. That's how much the car is worth. And that's 1/10 of its original value of 86,000. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.